Hello everyone, welcome back to PMAT1100. In this video, we will be discussing the last topic, the last concept in the first module. And the concept today is, I have to say that is pretty confusing to some students, and it's one of the hardest concept for the whole course. So I want you to pay attention carefully the lecture, okay? Before I start, I just want to ask you a question. Have you guys ever been to Vegas or to play casino? Have you ever been, or have you guys ever been playing gambling? Take a bet on something. I know several guys. He's not my friend, but some people I know in my country, in other countries. Then they gamble with William Hill. William Hill is one of the largest bet company in the world. One of the largest. Okay, and they gamble in the soccer game to see. They take a bet to see what team is winning for them right now. At this moment, we have Euro 2021, and this is happening in Europe right now. And they gamble what team is winning the trophy. So my friend, it's not my friend, and those people I'm talking about, they gamble, and the first couple games they won. Actually, they won, but at the end they always losing money. Sometimes we asking why. At the beginning they always winning, but at the end they always losing money. The reason behind is that, it's not just gambling. When you go to a casino, you play there's the machine thing, the roulette. You probably win the first few times, then finally you always lose. The reason is that behind all the bad company and behind all the casino, they are a bunch of mathematicians. And those mathematicians calculate the percentage, the likelihood, like how many percent, like what is the chance for you to win and what is the chance for them to win. So they calculate it in advance. So they know that if they let you win a couple times, let you guys win a couple times, then they know a way, they figured out a way to win back. So that's why every time you gamble, every time you take a bet, you always losing at the end. Okay, and all the mathematicians behind the casino and on the bet company, they use a concept. They apply the concept, math concept. The math concept, that's what we're talking about today. That concept we call the probability. It's just a change, the percentage of winning. So today we're gonna do the last. We're talking the last section in first module, section 1.6, probability. Okay, section. Let's get started. 1.6 probability. I don't know if I pronounce it wrong over here. Probability. Oh, I think I got it wrong. It's right here, it's with the I. Okay, probability. Okay, so what is the probability? Is it a chance of getting something? Is it a likelihood of getting something? Okay, there's two definitions of probability. Or for example, like a probability of raining today, a probability of winning lottery. This is the chance, the likelihood of getting something. So probability, okay, is likelihood, okay, of getting something. It's the likelihood of getting something. Okay. And there are two different types of probability we need to take a look in this course. The first type we call theoretical probability, and the second one we call experimental or empirical probability. But before we jump straight to the formula, let's talk about some few more definitions that you need to know. So the first definition is what probability is. Probability is a likelihood of getting something, likelihood of something happening. Something happening. And in order to get that likelihood, okay, you need to know the outcome. Okay, the outcome. What is the outcome? Okay, the outcome is the result. Okay, outcome is the result of outcome is the result. Okay, of an I think of an is the result of the I have to say that, let me see, is the result of that event. I shouldn't say the word event because it's in some textbook. The event, it means something. There's another definition for the event. Its outcome is the result of that event, of that things that happening. Okay. So I'm going to put over here, outcome is the result of let's see, let me use the appropriate word for this. Is the result of the event, but I'm going to put the event in quotation marks because in some textbook, event is something else, but especially in pre-calculus. But I mean, in this course, we it's a lower level, so I think I can use this. Okay, the result of the event. Okay, and the outcome, there's two different type of outcome. The first type of outcome is the total outcome. Total outcome. Okay, you mean the total number of possible of the things that really happening. Okay, you mean the total number of possibility. Okay, a possibility, you can say that, and the favorite outcome. What is the favorite outcome? It means the number of favor possibility. Possibility. you know, when we go through definition like this, I mean, I know that some students get kind of confused, but when we do in the example, then I'll tell you which one is the outcome, total outcome, which one is outcome, which one is favorite outcome, you know right away. Okay. And there's another thing I want you to notice is that this is important thing. And every time when you calculate a probability, okay, it should be because probability is a likelihood, it's a percentage. Okay, so the probability, okay, the probability is always between 1 and 100%. Between 0, greater than 0. I'm sorry, greater than 0 and less than 100%. So remark. Okay. Okay. Probability. So the notation for probability is P of the event. Okay. Of the E is the result. So P of the result. Okay. That's what I mean. Is always greater than 0. And less than or equal 1. I mean 100%. Well, it could be 0 or not. Some students ask me that could it be 0? The probability of getting something is equal 0. Well, it might. It depends on the question. But you know, every time we put a question, so I always want you to calculate the percentage. That means the answer shouldn't be 0, right? Okay, but it might. So I think I can put equal. It could be 0. Okay. I'm going to tell you exactly why it might be. It could be 0. Okay. It really depends on the question, depends on the situation, the scenario. Okay. Okay. All right. So that is the kind of the overall definition or definition we need to know in this lecture. And I already say that we have two different type of probability. The first probability I want you to take a look is theoretical probability. Okay. What is theoretical probability? Is this the percentage or likelihood of, again, it's the percentage or likelihood of getting something in theory. In theory. Okay, in theory only. It is not influenced, the result, the outcome is not influenced by the external, I just say that, the external force. Okay, the word force I'm gonna put in quotation marks. So it's not influenced by the external action. I can say that. Okay, it's not influenced by something else. Okay, and theoretical probability can be defined as. So I'm gonna put PE. P represent for event, for the outcome. Okay, the favorite outcome. Okay, is the number of favorable. Okay, favorable outcome. The number of favorable outcome over the number of possible outcome. The possible outcome over here means the total outcome. Alright, before I continue, let me check one more time and make sure that it's recording. Here you go, it's still recording. That's good. Okay, the number of favorable outcome, it means the outcome that you want, okay, over the possible outcome. Okay, I can give you a quick example like this. Example 1. Okay. Okay. What if I'm tossing a coin? Okay. So tossing a coin is a process, right? That process is an experiment. It's a process. Okay. Okay. It's a tossing a coin, and the outcome, the total outcome, it could be what? The total outcome, it could be head or tail. It could be head or tail. Right? It could be head or tail. Right? So this is the outcome. Head and tail is the outcome. Okay, and the total outcome over here is head and tail. So the total outcome, the total number of outcome is only 2 cases, head and tail. Head or tail. Okay, the outcome is head and tail. So this is an outcome. Okay. Okay. Now the question is, what is probability of getting a head? Okay. So we know that the outcome is head and tail, because the coin is only head and tail, right? Okay. And the total number of outcome is 2. Okay. So in order to get probability, in this case is theoretical probability. Okay. Because this in theory is not influenced by something else. I don't even need to toss the coin. I don't even need to toss the coin, and I know the probability of getting a coin. You know, over here I say that tossing the coin, but the coin is a head and tail, and I don't need to, right? And I know that the probability in this case will be theoretical probability. Getting ahead is the favorite outcome. So getting ahead right here is the favorable outcome. It's either, so there's only one case you get ahead, right? Because this other case is tail already. So the number of favorable outcome in this case for one coin is 1, right? Head, only one head. Okay, only one head. All right, over. Okay. Oh, what? Over the total outcome. The total outcome, the possible outcome. In this case, what? This other guy is the total outcome is just 2. Okay. It's just 2. Two possible outcomes, head or tail, right? And in order to get a head, it's just 2. Okay. So 1 over 2 will be 0.5. So the likelihood, the percentage of getting the head is just how many percent? 50%. Okay, it's 50%. All right. And you know, some textbook over here they say the number of total outcome. Okay, number of total outcome. And we here they say number of possible. I mean, it's kind of the same. Okay, but in some situation, in some scenario, it kind of very confusing. Okay, all right. Or I can give you an example like this. Rolling a dice. Rolling a dice. So this is experiment. Even though that I don't need to roll a dice. Okay. And all the total outcome is what? There's 6 phases, right? So it will be 1, 2, 3, 4, 5, 6. So this is the outcome. This is the total outcome. Okay, this is the total outcome. So rolling that experiment is a process. Well, we still consider as the theoretical probability because actually we don't need to roll the dice so that we know this is 1, 2, 3, 4, 5, 6. Because we know the dice is 1, 2, 3, 4, 5, 6. Then what is probability of getting 5? A 5. So 1, 2, 3, 4, 5, 6. There's only one case of getting the 5, right? One phase. Come over. You know, you roll the dice. You know, of course, 2 phases never come up, right? There's only one phase. There's one case. So probability in this case will be PE equal to number of failure. In this case, will be 1 because it's only number of 5. Excuse me. I'm sorry. Sorry for interruption. Nói nhỏ thôi. Sorry guys. And the number of total possible outcome, the total outcome must be 6. Right? 1 over 6. 1 over 6 give you how many percent? Is 1 over 6 is 1.166. So about what? About only 16.7% of getting a 5. It's kind of low. Okay, it's kind of low. So they all a theoretical probability in this case because it's in theory. It's not influenced by the result of the answer. The result, the probability is not influenced by the external force. I can say that force in quotation mark is not influenced by something from outside. We're not going to consider that we don't put wind into the consideration when you roll the dice, because you roll the dice probably the wind is going to influence the dice. No, we're not going to consider that case, or sometimes in the coil, maybe the coil is one phase is heavier than the other phase, then we're not considering that case either. The reason over here I say the toss the coin, roll the die. Actually, we don't need to. Right? We don't need to roll the dice. We don't need to toss the coin so that we know this probability of getting the head happening. We don't need to. That's why we call it theoretical probability. Okay. I'm gonna give you another example. This is a hard topic, okay? Especially when we jump into the empirical probability, and some student confusion. So I want you to pay attention. Example 3. Let's considering a cardiac. In cardiac we have we have 1, 2, 3, 4, 5. How many cars we have? 52 cars, right? 52 cars. So that is the total outcome. Okay, so what is the probability? Okay. What is the probability of getting what? Even though hold on, let me write out the question. So what is the probability of getting next? Okay, of getting an X. Okay, how many X in the codec? There are 4 of them, right? One spade, heart, one diamond, and what's the other one called? Spade, heart, diamond, and I just suddenly forgot. Spade, heart, diamond. I'm sorry. Let's look it up because I barely play cards. So spade, heart, diamond, and something else. I'm sorry. Let me look it up really quick over here. So spade, heart, diamond, and club. Spade, heart, diamond, and club. Okay. So they are one spade, one heart, one diamond, one club. Right? So PE, probability, will be what? Will be equal to the favorite outcome will be 4 of them, right? Because you want to get in I over what? Over the total outcome. The total. Okay, the total in the codec 52. 4 over 52. 4 over 52. It will be you simplified it, so it will be 2 over 26 and 1 over 13, right? Around 0.0769, so about 7.69% of getting an X. Okay, and this is theoretical probability, because you see that we don't need to do anything. We know right away there's a 4x in 52 car. Right. The total outcome, the favorite outcome is just 4. Okay. All right. Okay. So that is the theoretical probability. Okay. Now, on the second part, we'll be talking about the theoretical probability, and the other one, empirical probability. Probability. Okay. Okay. Empirical probability. Sometimes we call it experimental probability. I don't know if I spell this is wrong, so I think this is I right here. Okay. Empirical probability. Okay. So what is empirical probability, and how is different from theoretical probability? The empirical probability is different from theoretical probability when the outcome, the total outcomes, is influenced by something else. Okay, it's influenced by an action or by something else. Okay, by something else. And the empirical probability can be defined as is still P equal to the number of variable outcome over the number of trial. The number of trial. Actually, the number of trial over here is nothing but the possible outcome in theoretical probability. Okay, in theoretical probability. So in some cases, it's kind of hard to tell difference between those two types of probability. Okay, for example, how about it? Let me use the first example right over here, and then in theoretical probability, and I try to convert it into empirical probability for you to see. Okay. Okay. What if something like this? I'm tossing a coin. I'm still tossing a coin. But I'm tossing the coin 10 times. Oh, how about 5 times? Okay, so I'm tossing the coin 5 times. Okay, and the outcome is like this. The first time is head. The second time is still head. Third time tail. Then head. Then tail. So this is the outcome. Okay, that's the outcome. Question is, what is probability? Okay, of getting ahead? Okay, so the answer will be what? P will be favorite outcome. So this is what is really happening. We have head. So we have favorite outcome. The number of favorite outcome has, right, will be 3 over 5. Over 5. Okay, 5 is the number of trial, and you see that actually 5 is the number of the total outcome, right? You see that 1, 2, 3, 4, 5. So the number of trial, the number of outcome, you see that is kind of the same. Kind of the same. That's why in some textbook, I don't in Discord, I don't sometimes in Discord you see that we learn in the difference. We talking about 2 of them, but in some course, actually it's the same. It's still the same. Theoretical probability and empirical probability. This is the same in terms of definition. That's what I mean. Because the number of trial over here is the same as the number of outcome, right? The number of outcome is 1, 2, 3, 4, 5. In terms of definition, it's the same. But when we talk about the scenario, the situation is different, right? Because in this case, we see that we toss in the 5 times. You know, we have to do the tossing 5 times. Okay. So you see 3 over 5. So 3 over 5, 3 divided by 5 is just a 0.6. 0.6. So it's about 60%. So empirical probability is influenced by an actual result. It's influenced by that. It's really is influenced by what really happening. Influenced by the observation, really of what is happening. Okay, influenced by the reality. I can say so. Okay, I can say so. And another information is that actually, if you the more you tossing, okay, the coin, okay, the more it reaching to theoretical probability, the more it reaching to the likelihood of getting 50%. Okay, so this is theoretical probability. This is a very ideal case. It's an ideal case. This is what really happening. Okay, by an action, by the reality. Okay, by the reality. Let's see. Let's jump to another example. Let's see. Example 2. Let's see. Let's say I can use this example and convert into empirical probability or not. Rolling a dice 20 times. How about 20 times? Okay. What is probability? What is probability? Let me see. What is probability of getting a 5? Okay. Solution. So right now it's empirical probability because you see that the result is influenced by rolling the dice 20 times. What is the probability of getting a 5? So how will you do this? So you see that we have 6 phases in probability. The ideal case is probability of getting the 5 is 1 over 6. And now we rolling the dice 20 times. We rolling the dice 20 times. So how we gonna do that? We rolling the dice 20 times. So how many times you expected to have 5? So that's the question. How many times? How many times would you expect it to land on 5? How many times? What do you think? You know, if you roll a dice 1 time, so this is probability of one. The ideal case will be 1 time, right? But this is 20 times rolling the dice. So what will it be? What will it be? So in order to answer this question, Just think a little bit. Rolling your dice 20 times, so there's a one time to get a 5. Alright, one time is 1/6, right? So if you do 20 times, so in order to get the number of times to get it, you expect it to land on 5. You take 20, you divide it by 6. It's not a nice number. Yeah. So it's not a nice number. So the number of getting the 5 will be around 20 divided by 6. You know, it's not a nice number. So I think I'm gonna put 24 times so that it give you the nice number. Okay. So it will be 24 divided by 6 is 4 times, right? 4 times. Okay. 4 times you expect it to land on 5. Just think about this. So every time you roll a dice, okay, a possibility of getting 5, of getting into 5 is 1/6, right? Every time you roll a dice. But right now you rolling the dice 24 times. So you mean the possibility of getting the 5 just 24 divided. You take 24 divided by 6. It's just 4 times. That's the total you might get. It's the total. Okay, that's the total outcome. The total possible outcome. So if you want to get the probability of getting 5, the possible outcome is just 4. But in reality, how many 5 we get out of 4? Okay, what if I say over here in reality, you get out of those 4 times, okay, out of those 4 times you have only 3, okay, 3 times of getting 5. 5. Okay. So 3 times, it means 3 times you get in 5. That is the reality. That is the number of favorite outcome in that case. Okay. The number in the number of favorite outcome. It's only 3. The possible is 4. Alright, so over here, in order to get the probability, it's 3/4. 3/4, just which is how many? 3 divided by 4 is 0.75, which is 75%. Okay, 75%. It's kind of confusing over here. Alright, so think about it. One more time. Let's go through this. So if you roll a dice 1 time, right? The possible of getting a 5 just 1 out of 6. But because right now we have 24 times. Okay? 24 times. So the total will be 24 divided by 6. Actually, the highest possible you're going to get a 5 just 4 times. Okay? Just 4 times. But now I give you that in reality, it just you out of those 4 times, it's just 3. 3 times you get in 5. The last time you get maybe the other time you get 2 or whatever it is. Then you, in order to get the empirical probability, it will be 3/4. 3/4. Okay. Then it give you 0.75%. Okay, and 75%. Okay. So that is the answer for this problem. Okay, let's do one more. What if in the jar? Okay, in the jar like this. Okay, and there's 3 red ball. Okay, and 3 and 9 blue ball. Like that. 3 red and 9 blue. Okay, and the probability of getting red theoretically will be what? Okay, theoretically the probability of getting red will be p equal to 3 out of 12, right? Because the total will be 9 plus 12, the total. Okay, so it will be 1 over 4. 1 over 4, about 25%. Okay, but empirically, I say that I put out 3 times. Okay, I'm picking 3 times. Okay, and this is what happened. Oh, let's pick in 6 times. Okay, let's make it bigger a little bit. And this is what I get. I get red. I pick in 6 times and I put it back. Okay, every time I pick, I put it back. Okay, I put it back. Picking it 6 times and put it back. Okay, and the first time I get red, blue, red, blue, blue, blue. Okay, then what is the probability of getting red? Will be what? 1, 2 in reality, right? So there's a 2 over 6. The number of time picking, so it will be 1/3. Okay. Okay, so this is empirical. This is reality. That's really happening. Okay, this is really happening. You see, because in reality, I have only 2 red, but theoretically it should be 3, right? 3 out of 12. But in reality, it's just, so there's 6 times picking. So there's only, and 2 of them, 2 times I pick red. First time is red, third time is red. So 2 over 6. It's 1 over 3. Okay, so that is the last example I give, so that you can tell the difference between theoretical probability and empirical probability. Okay, so I think I'm gonna stop the lecture right over here. If you have any question for me, please let me know. This is a hard concept, so I want you to learn it carefully. Okay, and I'll be seeing you next time in the next video lecture. Okay, bye bye.